Hello everyone, welcome to Math World. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 3, which is the Pure Mathematics 3 for February-March 2020, and the code is 9709/32. So let's get started. For question number 1 is sketch a graph of y equals to modulus of x minus 2. Okay, so to sketch the modulus graph, let's sketch the graph without the modulus. That means we are sketching y equals to x minus 2. So let x be 0. Your y, it will be 0 minus 2. That is minus 2. Then we need to find another point because the x is with degree 1. So now I let y be 0. Then you will be getting x minus 2 equals to 0. Therefore, your x equals to 2. So here I get 2 points. Now with these 2 points, I can sketch the graph for y equals to x minus 2 first. So let's say here 1, 2, and these are the labelings. Okay, so now for the points, the first point is with coordinates 0, negative 2. So 0, negative 2 is below the x-axis, and the next point is x equals to 2, y equals to 0. Okay, so just for information, because we are actually sketching modulus x minus 2, right? These 2 points are for the graph without the modulus. Therefore, for the values, the y values below the x-axis, I will just use a dotted line. Okay, then for the values above the x-axis, it will be the straight solid line. So now the dotted line will be reflected in the x-axis because we are sketching modulus graph. Make sure the y is always positive. Therefore, it will be reflected to positive 2 for the y value instead of minus 2. And then just need to join these 2 points, these 2 cross, using ruler. And you will be getting a straight line. So this is the graph for y equals to modulus of x minus 2. Okay, so done for the graph. Now B, solve the inequality modulus of x minus 2 less than 3x minus 4. So now in the previous part, since we have sketched the modulus x minus 2, I can just add on this 3x minus 4 on the previous graph and check the intersection points. Okay, so then for 3x minus 4, I let it be y. This is 3x minus 4 because there is another method which is using squaring both sides. Okay, you use the definition of modulus, but that method will be longer because you need to do the checking, so which is not recommended. That's why you are asked to sketch the modulus graph in the part A so that you can refer to the graph to solve the B. So again, 3x minus 4 is a straight line because the x is with degree 1. Therefore, I just need to get 2 points. So when x 0, my y is minus 4. And then when my y equals to 0, I will be getting 3x minus 4 equals to 0, which means the x equals to 4 over 3. So here I have 2 points, y equals to minus 4 and y equals to minus 4, x equals to 0, and x equals to 4 over 3, y equals to 0. So now here I will simply sketch, right? So probably my minus 4 is here. This is minus 3. This is minus 3, minus 4. So now I'm getting 2 points. X is 0, y is minus 4. And then another point is x is 4 over 3, y is 0. 4 over 3 is 1 and 1 third, right? 1 and 1 third probably is here. So now I will just join these 2 points using dotted line because this is my working, right? So obviously, okay, it is a straight line. So from here, where you need to sketch, okay, so here I will write y equals to 3x minus 4. So when you need to solve this inequality, the modulus graph is less than the orange line, right? So obviously, it will be this part onwards. Okay, that means here onwards, right? Because the green line, the green line is always below the orange line. So that is tally with this, right? So from here, I need to find out the intersection point. which is this. This is the intersection point. But for your information, okay, this modulus graph, initially it was here, the dotted line. So this part is basically the reflected line. So when reflected line, the equation of this is actually y is negative of x minus 2. Because initially it was negative, then we reflected it to be positive by multiplying negative sign, okay, or negative 1. So it means that when I find the intersection points, there is only one intersection point here, therefore I have to solve these two, I have to solve these two simultaneous equations. Okay, so I will write negative of x minus 2 less than 3x minus 4. So bring the negative in, you will get negative x plus 2 less than 3x minus 4. Okay, then now the x will be moved to one side. So I move the minus x to 3x, and then the minus 4 will be moved to the other side, which means now you will be getting 4x on the right side, and is greater than my 2 plus 4. It will be 6. So if I rewrite, so basically this is x less than x is greater than 6 over 4. So since I divide the 6 by 4, okay, I have divided by positive 4. That means no need to change the sign, because when you read this inequality, actually we read from the right to the left. Therefore 4x is greater than 6. So your x is greater than 6 over 4. But if you are dividing a number by a negative value, then you need to change the inequality sign, that it will be less than. Okay, so in this case, you will be getting x greater than 3 over 2, which means whenever it is greater than this point, right? So the graph, the green line is always less than the orange line. So that is the explanation for the part B. Okay, so done for this 1B. Now next question number 2, solve the equation. Okay, ln 3 plus ln 2x plus 5 equals to 2 ln x plus 2. Give your answer in simplified exact form. So when exact form means that there is no decimal. Now I will rewrite the question. Ln 3 plus ln of 2x plus 5 equals to 2 ln x plus 2. Now for the left hand side, since there are 2 ln here, then I have one formula, that is ln a plus ln b equals to ln a times b. Okay, so now I group them first. That will be ln 3 times 2x plus 5. For the right hand side, since there's a 2 there, then I need to apply another formula. A ln b, that is basically ln b to the power of a. That means the 2 will be moved up to be the power of x plus 2. Then I will be getting ln of x plus 2 squared. Okay, so now the purpose for me to move up the 2 on the right side is because I need to get only one ln on both sides, so that I can cancel off the ln. Then from here I will be getting 3 times 2x plus 5 equals to square of x plus 2. Okay, because there's only one ln on both sides, then I can just ignore the ln. Now for the left hand side, so the question says solve. Solve means that you need to find the x, right? Then from here I will just do expansion for the left side. Then you will get 6x plus 15. Right hand side, it is a quadratic expansion. Then use this formula, a plus b squared, that is a squared plus 2ab plus b squared. Then you will be getting x squared plus 4x plus 4. Okay, so group all the terms on one side. Therefore, you will be getting x squared. So the 6x plus 15 will be moved to the right side. So then becomes 4x minus 6x, that is negative 2x. 4 minus 15, that is minus 11, that equals to 0. And now, this quadratic equation cannot be factorized. So if cannot be factorized, means that you need to use the quadratic formula. So now my coefficient for x squared is 1. That is a equals to 1. B is minus 2, and then C is minus 11. Then from here, my x is basically minus b plus minus square root of b squared minus 4ac over 2a. Just replace the values accordingly. then it will be negative of minus 2 plus minus square root of minus 2 squared minus 4a and minus 11 for your C. Then over 2 times 1. Okay, then from here, you will be getting positive 2 plus minus square root 48. Then over 2. So the square root 48, you can change to 2 square root 3. 4 square root 3, then over 2. And then at last, you will be getting 1 plus minus 2 square root 3. But then now, when you refer to the equation, okay, so here you have ln of x plus 2, ln of 2x plus 5. You have to make sure the x plus 2 and 2x plus 5 are positive after you replace the x. So then from here we know that 1 minus 2 square root 3 is negative, okay? So x equals to 1 minus 2 square root 3 is basically negative 2.46. So then ln of x plus 2 is undefined, right? When the x equals to this. So is undefined because negative 2.46 plus 2 is negative 0.46. Ln negative is undefined. Right? So therefore, your answer will be just 1 plus 2 square root 3. So this is the solution of the question 2. Okay, so for question number 3, by sketching a suitable pair of graphs, show that the equation second x equals to 2 minus half x has exactly one root in the interval between 0 and half pi, inclusive 0. So from here, I will let y1 equals to second x. Okay, and then y2 equals to 2 minus half x. So we know that second x is basically 1 over cos x. Right? So now, when you refer to the cos graph, and the interval is from 0 to half pi. So cos graph 0 to half pi is basically here. Okay, because this is your cos graph. So okay, so this is your cos graph. So y equals to cos x. Here's the x, this is the y. So then now, I need to sketch a graph. Okay, so then from here, when you consider 0, this is 0. Let's say this is pi over 4, pi over 2, and then here is pi over 4. Okay, so when x equals to 0, your y, the cos x equals to 1. So when you substitute into here, it will be 1. Okay, so probably I will just show you the table. Let's say this is x, this is y1, and y2. So when x equals to 0, okay, and then pi over 2. Even though it does not include pi over 2, but in the calculation we still use pi over 2. So when 0, look at here, cos 0 is 1. 1 over cos 0 is still 1. Okay, so when it is pi over 2, now when the cos pi over 2, it will be 0. So 1 over 0 for the y1, it will be infinity, which means I will be getting the asymptote. Okay, here I get 1. So now, because from 0 to pi over 2, the graph for the cos graph is basically dropping, decreasing. So for 1 over decreasing for the second x, it will be increasing up to infinity. That means this is your graph. Okay, then now for the next graph, y2. So when x equals to 0, I will be getting 2. And then when x equals to pi over 2, when you substitute into here, this function, I will get 1.2. So that means that this is 2. After that, here is 1.2. Probably is here. Then you just join these 2 points. It's a straight line. So I will label y equals to 2 minus half x. And the curve is basically y equals to second x. Okay, so this is the working. Alright, and now you need to show exactly one root. So when you are solving equation, okay, so this is y1 equals to y2, which means you look at the intersection point, right? So the number of intersection points will be the number of roots. So it means that here there's only one intersection point. So I will just write there is only one intersection point. So hence there's only one root for the equation. Has exactly one root. So the root here is the intersection point. Okay, so done for this question. Now B, verify by calculation that this root lies between 0.8 and 1. So I will just move the second x to the left side. Okay, so from here I will write 2 minus half x minus second x equals to 0. Then I will let the left hand side be fx and followed by the sign change rule. So let fx equals to 2 minus half x minus second x. You may move the straight line to the right side, so it will be the same. So now to prove that the root lies between 0.8 and 1, just replace the x by these two values. And then when you do calculation, make sure you change the modes of the calculator into radians because of the second, right? Then you will be getting 0.165, correct the three significant figures, and for F1 you will be getting 2 minus half times 2 minus half times 1 second 1. So the second is basically 1 over cos, right? So when you need to calculate second 1, that is 1 over cos 1 in radians, and this is negative 0.351, which is negative value. So then from here you just write f 0.8 is greater than 0 and f1 is less than 0. Hence the root lies between 0.8 and 1. Okay, so done for this part B. Now C, use the iterative formula. The formula is given to determine the root correct to 2 decimal places. Give the answer of each iteration to 4 decimal places. Okay, so now we'll rewrite the formula first. Now in the previous step we have shown that the root lies between 0.8 and 1. So you can let your initial x, which is the x naught, be any values in between 0.8 and 1, or probably you can just choose these two values, or I can just choose the middle value, which is 0.9. Okay, so now x1 equals to inverse cos 2 over 4 minus x naught, which is 0.9. And remember to calculate this using radians mode. So that is going to be 0.8696 because of 4 decimal places. Then now x2, it will be inverse cos 2 over 4 minus 0.8696. Then you will be getting 0.8777. And now you need 2 decimal places. So from here, look at here, they are not the same, so we have to continue. Then your x3, it will be inverse cos 2 over 4 minus 0.8777. and this is going to be 0.8756. Okay, so from here you are getting two equal decimal places. 8777 drop to 8756. So now just refer to the next digit. It is 5, so we round up. Therefore, I will say x is almost 0.88. So that is the estimator of the root. Question number 4. Find integration of x second square x dx with the limits of pi over 6 and pi over 3. Give your answer in a simplified exact form. So, to integrate pi over 6 to pi over 3 x second square x dx. Now, this is product of two functions of x, right? Therefore, to integrate this, I need to apply the integration by parts. Okay, so for integration by parts, our formula is integrate u v prime dx equals to uv minus integrate v u prime dx. Okay, or u dv dx, right, up to u. So then from here, our u is x. Okay, then the v prime, it will be second square x. So now your u prime is x. You differentiate x with respect to x is 1. Sorry, u prime is 1. Then the v is integrate tangent second square x dx. That is going to be tangent x, because when you differentiate tangent x, that is second square x. Then now, use this formula, integration by parts, right? It will be uv. So I will get x tangent x with limits. For your information, if you have limits ab, then you need to consider limits. Okay, this is minus. So here ab, then limits ab. Right? Then you will be getting limits pi over 6 to pi over 3 minus integrate v du. So v du, which is tangent x dx. So then for the first term, replace the x by pi over 3, then minus when the x is pi over 6. That means you will be getting pi over 3 tangent pi over 3 minus pi over 6 tangent pi over 6. Then minus, now to integrate tangent x, we need to change to sine x over cos x. Okay, so for the left hand, for the first two terms, the tangent pi over 3 is basically square root 3. Tangent pi over 6, you will be getting square root 3 over 3. Okay, then minus, for the integration, we are going to use another formula, f prime x over fx. Integrate f prime x over fx dx. This is going to be ln fx plus c, which is the ln formula. Now, for information, when you differentiate cos x, okay, because the cos x is the denominator, when you differentiate cos x is negative sine x, so I times a negative inside the integration, and then I times another minus outside, because when you times a negative inside, you must balance back with the negative outside the integration, which means now you are getting this. Okay, so outside the integration, it will be minus minus is a plus. So I will write plus. Then for the whole integration, which means this whole integration, that is going to be ln formula. So I will be using ln cos x, then with limits pi over 6 to pi over 3. Okay, then from here, right, for the first two terms, I can just factorize the pi over 18, because denominator is the first denominator is 3 and the second denominator is 18. So I would say that the common term is pi over 18. And then now when I factorize factorize 18 from the denominator, first term you still have 6. Okay, then for the second term you still have the square root 3 there. Alright, so basically the square root 3 also in common, I should factorize the square root 3. So here, factorize square root 3. So then you will get 6 minus 1. Then plus, replace the x by pi over 3 right now. So it will be ln cos pi over 3 minus ln cos pi over 6. Then the first term, you will get 5. 5 square root 3 over 18 pi. Okay? And then the next one, ln cos pi over 3. Cos pi over 3 is half. So you get plus ln half. Then minus ln cos pi over 6 is basically square root 3 over 2. Right. So then from here, I will get 5 root 3 over 18 pi plus. Now, again, I have 2 ln. So when it is minus of subtraction of 2 ln, that is going to be division. So ln A over B. Okay, because ln A minus ln B. Then means you will be getting ln half divided by square root 3 over 2. So then from here, the denominators will be cancelled off. So you will be getting 1 over square root 3. So then I will be getting 5 square root 3 over 18 pi plus ln 1 over square root 3. Okay, so ln 1 over square root 3 as simplified exact form. So which means now here I can change to 5 square root 3 over 18 pi. So this ln 1 over square root 3 is basically negative ln square root 3. Okay, because this is actually ln 1 minus ln square root 3. So ln 1 is 0. That means here the square root 3 I can just change to 3 degree half. Then the 3 degree half you can write 3 degree half, that is half ln 3. It's because of this formula. Ln A power B is B ln A. Okay, that means now here I will be getting 5 square root 3 over 18 pi minus half ln 3. So that is the simplest form. Question number 5a. Show that the left side equals right side. So it means that you are proving the identity. So now I will start from the left hand side. Since there are 2 terms on the left hand side, easier to simplify. Okay, then from here I will get the same denominator by using cross multiplication. Just cross multiply. So then that is over sine x cos x. So the first term will be cos x cos 3x, then plus sine x sine 3x. Now we have an identity. Cos A minus B, that is cos A cos B plus sine A sine B. Okay, therefore now my A is x and my B is 3x. Oh, sorry, this is plus. So when it is plus, then here's plus, this is going to be minus. Probably I will just write both. Plus minus, it will be minus plus. Okay, so then from here, I will just need to rearrange. Instead of 3x as the second term, I will just rewrite. That means I change to 3x as first term, x as second term. So it will be the same. But when I substitute into this formula, my A is 3x. Okay, A is 3x, then my B is x. So it means that now, since this is plus here, then I choose a plus, the lower sign. So which means it's cos of 3x minus x. Then I will be getting, this is cos 3x minus x over sine x cos x. Okay, then now you look at here. This is cot 2x. Cotangent 2x is actually 1 over tangent 2x. So again, for the denominator, sine x cos x, I will change to another identity. Okay, so it will be sine 2x equals to 2 sine x cos x. Therefore, keep the sine x cos x one side by moving the 2 to the other side, which means now sine x cos x is basically half sine 2x because of the 2x here. Okay, so I will be changing the denominator into half sine 2x. Then with this, my numerator becomes cos 2x. Okay, now you see there is a half in the denominator. So 1 over half is basically 2. So I will just write 2, then over sine 2x. Right? So cos 2x over sine 2x is basically tangent, cotangent 2x. Right? So I have proven the identity, 2 cot 2x. Can that be? Hence means solve. Oh, no. Hence means use the previous answer, solve the equation. So the left side is basically same as the identity just now. Okay, then equals to 4 and the x is from 0 to pi. So then I know that's the left hand side based on previous part. That is basically 2 cot 2x. Okay, it's here. So which means now instead of solving this original equation, I'm actually solving 2 cot 2x equals to 4. Then the x is from 0 to pi. Then from here, I will get cot 2x is 4 over 2. That is 2. Cot 2x is 1 over tangent 2x. Then by moving up the tangent 2x to the other side and move down the 2, so I will be getting tangent 2x is half. Okay, now you are given the interval of x and now we are solving 2x. That means now I have to find out what is my 2x interval. So just times 2, which means it will be in between 0 and 2 pi. Okay, and then after that I will continue with the quadrant. Because now tangent is positive, so it will be in first and third quadrant. Okay, so I will write down basic angle is basically inverse tangent half. Using calculator in radians mode, that is going to be 0.4636. I give more decimal places here or more significant figures here because this is the working. Right, this is going to be 0.4636. And then now we are solving 2x. The first value, okay, look at here. The first value will be 0.4636. And now look at the interval. Your interval is from 0 to 2 pi, which means it will be 4 quadrants. Right, so the second angle will be pi plus 0.4636. So then I will write 0.4636 and another one is pi plus 0.4636. Then you will be getting the next value as 3.6052. Okay, now to get the x, just divide by 2. That is going to be 0.2318 and the other one is 1.8026. And now remember, final answer always 3 significant figures for the angles in radians. So now you will get 0.232 and the other one 1.80. Okay, so done for this question. Okay, question number 6. The variables x and y satisfy the differential equation. Given x equals to 1 when y equals to 0. Now A, solve the differential equation and obtain the y in terms of x. So now dy dx equals to 1 plus 4y squared over ex. So then I need to separate the variables. So the dy is the numerator, therefore all the y should be on the left side. Then I move this 1 plus 4y squared to the left side, it becomes 1 over 1 plus 4y squared. And then here dy equals to 1 over ex dx. Okay, now when you need to integrate the left hand side, we have one formula, that is integrate a over a squared plus x squared dx. That is going to be inverse tangent x over a plus c. Okay, and then to integrate the exponential function e mx plus b dx, that is rewriting the whole exponential function and then differentiate the power of e. So when differentiate mx plus b, that is m. So we divide by the differentiation. So these are the two formulas that we are applying in this question. Okay, then from here, the left hand side, I will change to the original form. That means now when you look at the first formula, inverse tangent x over a plus c, to make sure, to use this formula, make sure the coefficient for x squared is 1. Okay, that means now your x becomes the y. So now, right now, the coefficient for y squared is 4. So which means I need to factorize the 4. So once I factorize the 4, supposedly 1 over 4 plus y squared. Okay, but when you look at the formula, this is a squared. So the 1 over 4 I change to square of half. Then dy. Then for the right side, it will be e negative x dx. Okay, and then from here, the 4 will be taken out. 1 over 4. Integrate. Now this integration, okay, supposedly here is a, but then there's 1. So which means my a will be moved to the other side. So which means now here, I will not write a on the numerator. Then I will write here 1. Then the a moved to the other side becomes 1 over a. Okay, this is a formula. Which means now here, I will be getting 1 over half. Because my a is half. So 1 over half. That is my 1 over a. The inverse tangent y over my a is half. Okay, then for the right side, rewrite the whole exponential and differentiate the power of e. Differentiate minus x, you get minus 1. So over minus 1 is same as times by minus. Then here plus c. Okay, I simplify first. 1 over 4 times 1 over half. So this 1 over half is basically 2. So that means 1 over 4 times 2, you are getting 1 over 2. So basically, you are getting 1 over 2. The inverse tangent y divided by half is basically 2y. That equals to negative e negative x plus c. And now, to solve this equation or differential equation, you need to get y in terms of x, which means firstly I need to find a c. So you have to find a c by replacing the x and y values. X is 1, y is 0. That means now you will be getting half inverse tangent 0 equals to negative e negative 1 plus c. Okay, so inverse tangent 0 is 0. This is 0. So then, to get the c, the negative e negative 1 move to the other side. That means your c is e power negative 1, which is 1 over e. Okay, then now substitute this c into the equation. So means that I will be getting half inverse tangent 2y equals to negative e negative c x. Then the plus c is plus e negative 1. Okay, so now to get the y as a subject, when you look at the question over here, then I have to move the half to the other side, means I times 2 the whole equation. So which means inverse tangent 2y is 2 of e power negative 1 minus e power negative x. So then move the inverse tangent to the other side. So it will be tangent of right side. So the 2 you can move in. So I get 2e negative 1 negative 2e negative x. Right? At last, to get the y. So just divide by 2, which means half tangent 2e minus 1 minus 2e negative x. So this is your solution for the differential equation. Okay, now B, state what happens to the value of y as x tends to infinity. So now I will rewrite. This is my y. So when x tends to infinity, right? So e minus x, this is basically 1 over ex. So we know that when x tends to infinity, ex will tend to infinity. So 1 over infinity will tend to 0. That means now the y approaches half tangent 2e power negative 1 because the e negative x tends to 0 when the x approaches infinity. So that's the solution for part B. Okay, now for question 7, the equation of a curve is x cubed plus 3xy squared minus y cubed equals to 5. So show this differentiation. So now basically you are given the implicit equation, right? So now x cubed plus 3xy squared minus y cubed equals to 5. So to get dy dx, basically you are differentiating the whole equation with respect to x. So first term, when you differentiate x cubed, that is going to be 3x squared. Now for the second term, okay, basically this is product of two functions. The first function is 3x, the second function is y squared, which means now I need to differentiate this using products rule. That is uv prime plus vu prime. So then, now, when you keep the 3x, right, and then you differentiate y squared, that is our v. So then from here, differentiate function of y with respect to x, right? So you have to apply the implicit differentiation, or I would say this is a chain rule. So now your fy is a function with in terms of y. That means when you differentiate, you should differentiate with respect to y. Okay, then after that, you have to times by dy dx according to the chain rule. That will be the differentiation of function of y with respect to x, which means now when I differentiate x squared with respect to x, firstly I will differentiate the y squared, when I differentiate y squared with respect to x, firstly I will differentiate y squared with respect to y. That is going to be 2y. Then after that, just multiply this dy dx. Okay, and now plus here vu prime, keep the y square and differentiate 3x with respect to x, that is 3. So same goes to the third term, when you minus differentiate y cubed with respect to x, that is going to be 3y squared dy over dx, that equals to the 5 becomes 0. And now we need to get the dy dx as a subject. So by looking at the left side, all the terms on the left side, basically you can divide the whole equation by 3. Okay, so when I divide by 3, I will be getting x squared plus 2xy dy over dx, then plus y squared minus y squared dy over dx equals to 0. Okay, then from here, because when you look at the given answer, this is basically the denominator initially together with the dy dx. So I know that once you have factorized dy dx, right, from the common term, then from the second and third and the fourth term, you should get y squared first. So which means now, to get that form, these two terms will be moved to right side because I need to get positive y squared. So which means now I will be getting x squared plus y squared equals to y squared dy over dx minus 2xy dy over dx. And then I will factorize the dy dx from the right side. So once I factorize, I will be getting y squared minus 2xy. Okay, then from here, I can easily get my dy dx by moving the bracket to the other side. So my dy dx equals to x squared plus y squared over y squared minus 2xy. So that is the solution of this part A. B. Find the coordinates of the points, so more than one point, on the curve where tangent is parallel to y-axis. Okay, for your information, if let's say tangent is parallel to x-axis, means dy dx equals to 0. Okay, tangent is parallel to y-axis, which means here. This is tangent parallel to y-axis, right? That means if the dy dx equals to 0, means that the numerator of the dy dx equals to 0. Okay, so now this is not 0, but the denominator equals to 0 because of the tangent, right? So which means now I will write the denominator will be 0. So dy over dx, I rewrite this expression first. X squared plus y squared over y squared minus 2xy. So now y squared minus 2xy equals to 0. Okay, then now you need to find coordinates of the points. So it means that more than one point here. So when we solve this equation, the common term is y. Factorize the y to get y minus 2x times y. Then now either y equals to 0 or y minus 2x equals to 0. So which means either y 0 or y equals to 2x. And now we need to find out the points. Therefore, I need to substitute that two results, okay, these two results into my curve equation. So which means I need to rewrite my curve equation right now. So x cubed plus 3xy squared minus y cubed equals to 5. When y equals to 0, I will get x cubed equals to 5. Therefore, my x is cube root of 5. This is my first point. Okay, then the second one is when y equals to 2x. Therefore, I need to substitute y equals to 2x into my curve equation. Let's say this is first equation and this is the second equation. Okay, so now I substitute second into first because I need to solve the equations. Therefore, you will be getting x cubed plus 3x. My y is 2x, so 2x squared minus y cubed, so which means 2x cubed equals to 5. That means now here you will be getting x cubed plus, okay, square of 2 is 4. 4 times 3, 12. Then x cubed. Cube of 2 is 8. The total of the left hand side is 19 minus 8, which is 11. Not 19. This is 13. 13 minus 8, that is 5. Okay, 5x cubed. So 5x cubed is equal to 5, which means x cubed equals to 1. Therefore, your x is 1. Okay, so when x is equals to 1, the y equals to 2. So now, from second equation, x equals to 1, your y is 2 times 1. Therefore, you are getting 2. Now, final answer, the points with coordinates cube root of 5 followed by 0, and another point is x is 1, y is 2. So done for this question. Okay, now for question number 8. in the diagram, you are given a cuboid where OA is 2 units, here is 2i, and then OC is 3 units, that means OC is 3j. And then OD is 2 units, so OD is 2k. Okay, now unit vectors ijk are parallel to OA, OC, and OD respectively. The points M on OB such that MB is 2AM. So MB is 2AM. Okay, so now the midpoint of FG is N, right? FG, this is midpoint. Now A express the vectors OM and MN in terms of ijk. So to get the point M, right, I need to use this information. MB equals to 2AM, so I will say that MB, vector MB, equals to 2AM. Right, so MB is 2AM. Alright, so MB is basically, okay, then from here I will say I use the ratio, okay, because I can find OM. Let's see OM. OM, okay, which is here. OM is basically OA plus AM. So I just need to find out what is my AM. So then from here, MB is 2AM. That means when I consider the ratio, right, MB is 2AM. That means AM over MB. Okay, AM over MB. Move down the MB. This MB, you move it down. So the 2 you move to the other side. That means it's 1 over 2. Okay, so from here I know that AM, the ratio AM to MB is basically 1 to 2. So when 1 to 2, I will say that my AM, vector AM, is basically 1 over 3 of AB. Okay, because AM is 1, MB is 2. So AM is 1 over 3 of AB. Right? So here, AB. Because we know that AB is basically is actually in the same direction as OC, which is 3J. So then from here, I will say this is 1 over 3 of 3J, which is J. That is my AM. And now I can find my OM. So my OM is basically OM, look at here, OA plus AM. So OA, okay, I have not enough space, so therefore I have to rewrite my solution so that I have more space. Sorry about that. So that means here, right, I will write AM equals to 1 over 3 AB. That is 1 over 3 of 3J. That is J. That is my AM. So my OM equals to OA plus AM. So my OA is basically 2i. Okay, so that is 2i plus 3 plus 1j, because my AM is 1j. Okay, done for the OM. Now for the MN. So look at here, MN. So MN, I will say that it is MB plus BF. Okay, plus BF. And then plus FN. That is my MN. Okay, so MN equals to MB plus BF plus FN. So my MB just now, Okay, 2 out of 3 of AB. So here is 2 over 3 AB. And then my BF, just write BF because BF is same as OD. So just write BF. Then now my Fn. Okay, look at here. N is the midpoint of F and G. So Fn, this direction is actually opposite direction of the AO. So that means it's half of AO, which is negative, or I would say half of AO. Right? Then here it will be 2 over 3. AB is 3J. BF will be OD, same. So it will be plus 2K. And then half AO. AO is in the opposite direction as OA. That means it's negative half of 2I. So at last, when I rearrange, the last one will be negative 1I. Then for the J, you can cancel off the 3 here and the quarter and the 1/3. Then you'll be getting plus 2J at last plus 2K. So that is your MN. Part B, find the vector equation for the line through M and N. Okay, so M and N basically, firstly you need to find R equals to OM plus TMN. Okay, this is the vector equation of the line. So we have found the OM just now, 2I plus J. So it will be 210 plus T times Mn, already found here as well, minus 1I plus 2J plus 2K. That means it will be minus 1, 2, and 2. That is your vector equation of the line through M and N. Now see, find the position vector of P, the foot of the perpendicular from D to the line through MN. Okay, so where is a D? D is over here, right? Now, let's say I draw like this. Your MN is here. This is your M, this is your N, and the D is somewhere here, right? Find the perpendicular, find the P such that there is a foot of the perpendicular from D. So from D, 90 degrees to the line MN, and this is the P. So you need to find out what is your OP. So from here, I know that P lies on the line MN. That means OP equals to R. Okay, equals to the equation of the line MN. So that means here it will be same as, just rewrite from the previous part. 210 plus T minus 122. Then now, the D, okay, so from here I know that the DP is perpendicular to MN because here is 90 degrees. So since they are perpendicular, I will just write DP, vector DP, dots with MN equals to 0 based on the scalar products formula. So now the DP equals to OP minus OD. Okay, so just rewrite this and open the brackets. You will be getting 2 minus T, 1 plus 2T, and then 0 plus 2T, so it means 2T, minus my OD based on the cuboid. So OD is 2K. 2K means 0, 0, 2. Okay, then from here, I will be getting 2 minus T, 1 plus 2T, then minus 2 plus 2T. That is my DP. And now I substitute into the dots product. So 2 minus T, 1 plus 2T, minus 2 plus 2t dot with mn. So my mn is basically minus 1 to 2. This is my mn. And equals to 0. Okay, let's say this is 1. So from 1. Now the dot product means that you need to multiply the corresponding components. So here I will be getting minus 1 times 2 minus t plus 2 times 1 plus 2t plus 2 times minus 2 plus 2t, then equals to 0. So when you times, open the brackets, write all the brackets, so I will get minus 2 plus t plus 2 plus 4t minus 4 plus 4t equals to 0. So the total of the t there is 9t. Then all the numbers, when you simplify, minus 2 and plus 2 is 0. So this minus 4 move to right side, it will be positive 4. Which means now your t is basically 4 over 9. Okay, so with the t equals to 4 over 9, then we can find the OP. That means with that t, the dp is actually perpendicular to the mn. So now, my OP becomes 210 plus, or I can just substitute into this, because that is my I need to find position vector of P. Okay, so position vector of P means I have to refer to the OP. It's not the DP, right? So then my OP is 210 plus T. So 210 plus T of minus 1 to 2. Okay, then this is going to be, so 2 minus 4 over 9, that is 14 over 9. 1 plus 2 times 4 over 9, that is 17 over 9. And then 0 plus 2 times 4 over 9, that is 8 over 9. Okay, so you can leave your answer in this form or probably in terms of IJK. So let's see the question first. Okay, never specify any forms. You can leave it in the column vector or IJK form. So just rewrite. So done for this question. Okay, question number 9. Given fx, express fx in partial fractions. So first of all, I have to check whether this this function is proper or improper rational functions. Okay, so look at here, highest degree of 4x is 2 in the numerator, but when you do expansion for the denominator, that is 3. Therefore, this is proper rational function. So when proper rational function, we can just direct find the partial fractions. Now, since you are given 3 linear factors in the denominator, your partial fractions will be a over first linear factor plus b over second linear factor plus c over third linear factor. So now just compare with the left hand side to get the same denominators, which means here I will be getting a over 1 plus 2x. So I need to times with another 2 factors. Then you will be getting the same denominator as on the left side. Now for the b, it will be b over 1 minus 2x. Then you times with, okay, 1 minus 2x already there. So you times with another 2 factors. So the first and third factors. And for the C, you are given the third factor now, so multiply with the first two factors because this is given. So multiply with first two. Okay, once you have obtained all the same denominators, basically we can just cancel the denominators. Then we just need to rewrite all the numerators. So which means now here I will be getting 2 plus 11x minus 10x squared that equals to a times 1 minus 2x and then 2 plus x plus b times 1 plus 2x followed by 2 plus x and then lastly plus c bracket 1 plus 2x and then 1 minus 2x. Okay, so now to get the unknowns a, b, c, just let the factor be 0. So firstly I let 1 minus 2x be 0. That means now your x is going to be half. So when I substitute half into the equation, the left hand side will be 2 plus half 11 times half minus 10 times half squared. So which means now for the right side, as long as you see 1 minus 2x, that will be 0. So 1 minus 2x, this is 0. And the last term will be 0. That means you can find the b directly. So which means now here you will be getting equals to b of 1 plus 2 times half multiply with 2 plus half. Then for the left hand side, you will be getting 5. Right hand side, b bracket 1 plus 2 times half is basically 2. Then the other one is 5 over 2. So now the half and 2 will be cancelled off. So it means that 5b is 5. So here I get 5b is 5. Hence b is 1. Found the first unknown. Now next is let 2 plus x be 0. Okay, which means the next term also 0. Then you can find the c. So now let 2 plus x be 0. That means now your x equals to minus 2. So I replace 2 plus 11 times minus 2 minus 10 times minus 2 squared equals to, just find the c, 1 plus 2 times minus 2 and then 1 minus 2 times minus 2. That means now here left hand side you will be getting minus 60. Then the right hand side is c bracket 1 minus 4 is minus 3. Then 1 plus 4 is 5. Therefore, I will be getting minus 60 is minus 15c. So that means your c is 4. So done for the c. And now to find the remaining unknown, I let the other factor be 0. That means I let 1 plus 2x be 0 right now. That means now the b and c already you can't find. Then you have to find the a with that value of x. So let 1 plus 2x be 0. That means the x is negative half. So 2 plus 11 times negative half minus 10 times negative half squared equals to a bracket 1 minus 2 times negative half, then 2 plus negative half. So for the left hand side, that is minus 6. Then here will be a bracket 1. This is basically 1 plus 2. 1 plus 1, that is 2. Then 2 minus half, that is 3 over 2. So the 2 and half cancel. You will be getting minus 6 is 3a. Hence the a is negative 2. So with this, I can find the fx. Okay, just rewrite. Replace the a, b, c. So the fx is a over 1 plus 2x. That means it's negative 2 over 1 plus 2x. And then plus b over 1 minus 2x. So now my b is 1. So plus 1 over 1 minus 2x. And then plus c. So 4 over last factor. Last factor is 2 plus x. So done for the partial fractions. Now b. Hence obtain the expansion of fx in ascending powers of x up to the term in x squared. So now I will rewrite all my fx first. That is minus 2 over 1 plus 2x plus 1 over 1 minus 2x plus 4 over 2 plus x. Okay, so I will move up all the denominators. Move up first. Now, since all the powers are negative values, okay, so that means to do the expansion, we need to use this binomial expansion formula. That is 1 plus nx plus n times n minus 1 over 2 factorial x squared and so on. Because here, just up to x squared. And now, to make sure that you can use this formula, you have to make sure the first term is 1 and followed by plus. The x can be any multiple of x and can be negative as well. But it must be 1 and plus. So which means the first term no problem. Second term you can change. Third term you have to factorize 2. So I will rewrite. So here second term becomes 1 plus negative 2x power negative 1 plus 4 factorize a 2. So 2 bracket 1 plus x over 2 power of negative 1. Then now you can just do expansion. The first one is minus 2, rewrite, and then substitute into this formula. That is going to be 1 plus, your n is minus 1, x is 2x. Then plus n minus 1 means that minus 2, then over 2 factorial. After that, x squared. This is your first expansion. And then the second expansion is, I will just rewrite here. Now, it will be 1 plus, the n is minus 1, and then now the x is minus 2x. After that, plus minus 1 minus 2 over 2 factorial minus 2x squared. That is my second expansion. Now, for the third expansion, you have to be careful because there is a 2 here. And this power negative 1, we will have to bring it in. That means 2 with degree of minus 1. Then multiply with the 4. So plus 4, 2 degree minus 1 is basically half. Then after that, do expansion as well. So 1 plus, now your n is minus 1. Now your x is x over 2. Okay, plus minus 1 times minus 2 over 2 factorial x over 2 squared. So now what we need to do is just to simplify these three expansions. So I will be getting minus 2. Then 1 minus 2x plus 4x squared. Okay, so for the second expansion, that is going to be 1 plus 2x plus 4x squared. So simplify. Okay, because negative 1, negative 2 is 2. So 2 over 2 factorial, that is 1. Then now, last expansion, the half and 4 cancel off becomes 2. Okay, then here it will be plus 2 with 1 minus x over 2 plus x squared over 4. Okay, lastly, just open all the brackets. So I will get negative 2 plus 4x minus 8x squared from first expansion. Then plus 1 plus 2x plus 4x squared from the second expansion. And the third expansion, multiply the 2, bring in the 2. Then you will get 2 minus x plus x squared over 2. So now when we simplify, okay, because of ascending powers of x, so initially constant. So that means minus 2 plus 1 and plus 2. So minus 2 plus 2 is 0. Then you plus 1, that becomes 1. So I get 1. Then for the x, positive 4x, positive 2x. So 6x, 6x minus 1x, that is 5x, positive. So for the remaining terms, when you add up and simplify, that is going to be negative 7 over 2x squared. So this is the expansion up to x squared. Question number 10. A. Complex numbers W and V and W satisfy the equations. These two are the equations. Solve the equations for V and W. Give your answer in the form of x plus iy, where x and y are real. Okay, so V plus iw is 5. Let's say this is first equation. And then 1 plus 2i multiplied with V minus W equals to 3i. So when we need to solve this, right, I can just use the elimination method by changing the second equation from negative w into negative iw. Means that I times I to the second equation. So when I times I to the second equation, the 1 becomes I. Then the 2i becomes 2i squared. Then followed by minus iw equals to 3i squared. And now I simplify. We know that I squared is minus 1. Alright, so here I will get minus 1 times 2. That is minus 2 plus I multiplied with V minus iw equals to I squared is minus 1. So minus 1 times 3 minus 3. That is my third equation. So we can solve the first and third equation right now. And when you look at the iw, the first equation is plus, and from the third equation that is minus. That means now I will plus both equations. So first plus third. Okay, then now since the first term both also v, I can factorize the v, and then once you factorize the v, the first term is basically 1v. So I will have 1 then plus with negative 2 plus I. That is the coefficient of the v in the third equation. Okay, so now the iw cancel off already because 1 plus 1 minus, and you are adding, that equals to right side 5 plus minus 3, that is 2. And then from here, I will say v times, open the brackets. So 1 minus 2 is minus 1, then plus I equals to 2. Then from here, I just need to solve v is 2 over minus 1 plus I. So to solve this, we need to times the conjugate of the denominator, which is minus 1 minus I. Then here I will be getting over, for your information, a minus bi times a plus bi, that is real squared plus imaginary squared. So my real is minus 1. So I squared it. My imaginary is 1. Okay, imaginary parts plus is 1i. So 1 squared. So for the numerator, just do expansion, minus 2 minus 2i. Then you will be getting minus 2 minus 2i. The denominator, it will be 2. Okay, minus 1 squared is 1. 1 plus 1 is 2, so over 2. Therefore, the answer is minus 1 minus I. That is the v. So once you have found the v, we can solve the w. So now, to get the w, okay, I can refer to the first equation. V plus iw equals to 5. So v plus iw equals to 5. Right? So now, to get the w, iw is move the minus 1 minus I to the right side. So you will be getting 5 plus 1, which is 6 plus I. Okay, probably I will just do step by step. Then your W is 6 plus I over I. Then now I will times minus I over minus I. And now I times I is minus 1 in the denominator. Minus 1 times minus is a positive 1. Then times in the minus I. With the 6 plus I, you will get minus 6I minus I squared. And again now, the I squared is minus 1. Here, this is minus 1. So minus 1 times minus is a plus 1. So I will write 1 minus 6I. Okay, so done for the W. That means now your V is basically minus 1 minus I. And then the W is 1 minus 6I. Okay, so parts B. First part. On an Argand diagram, sketch the locus of points representing the complex number Z satisfying this. So this is basically a circle. But circle, we need to get the center and also radius. So it will be Z minus 2 plus 3I once you factorize a negative. Then equals to 1. That means this is a circle with center 2, 3. Because of 2 minus 3, 2 plus 3I there. 2, 3 and radius 1. Because of right side is 1. Okay, so now center is 2, 3. So let's say here 1, 2, 3, 1. Okay, 2, 3. This is the imaginary axis. And here is a real axis. Now our center is at 2, 3. So 2, 3. Radius is 1. That means 1 unit to right, left, and then up and down. Okay, so this is our circle. Just draw a smooth circle. Okay, so this is modulus of Z minus 2 minus 3I equals to 1. That is a locus. Okay, now part 2. Calculate the least value of argument Z for points on this locus. So the argument is actually the angle counted from the origin, okay, towards the points on the circle. So now we know that we need to find least value. Least value means that probably it will be here. Okay, this is the least value. So you need to find what is this argument Z. Okay, so then now to find this argument Z, right, we know that you can find the argument for the center. You need to draw a straight line here. You can just join the center and the origin with ruler. Okay, because I don't have ruler here. So now I can find this angle. This one's supposed to be 2. Okay. So I can find this angle. Let's say this is theta. This orange color is theta. And then here, for the least, it must be 90 degrees over here. That's why it's called least. Right? This is a tangent line. Okay, the blue line is a tangent line. So from the, let's see, okay, here is 90 degrees. From the center to the tangent line is always perpendicular. Then I can find this as well. This is my alpha. So basically my argument z is the theta minus alpha. Okay, that is the least argument z. And then we know that the radius is 1, which means here is 1. Okay, so from here I will say that my theta can be found using the right angle triangle, the green color. Okay, so my theta, well, probably I just draw the triangle. So the horizontal value here, the horizontal distance is 2. This is the O, right? Then the vertical is 3 because the center is at 2, 3. This is the center. So this is your theta. So now my theta is basically inverse tangent 3 over 2. Right, opposite adjacent. Then this is going to be 0.98279. And now, when you refer to the triangle with alpha value, okay, this is alpha. Here is 1 because of radius is 1. Now I need to find out what is my hypotenuse, which is this green color. So this green color is also the hypotenuse of the green triangle. That means now I need to find out what is this. Okay, so I let that be x. So x can be found using Pythagoras theorem because that is the hypotenuse. So the x is basically square root of 3 squared plus 2 squared. That is square root of 9 plus 4. Then you are getting square root 13. Then here I will label square root 13. And now my alpha value, right? This is 2, 3. The coordinates 2, 3. Here coordinates 2, 3. Right? And then now here to find the alpha, I prefer using tangent, inverse tangent. Therefore, this is origin. Okay, origin 0, 0. Then this length, okay, it will be hypotenuse. I mean the Pythagoras theorem. That is square root of square root 13 squared minus 1 squared. Then you will be getting square root of 12. So now my alpha is inverse tangent of 1 over square root 12. Then you will be getting 0.28103. So least or the least argument z. Based on my diagram, the least argument z is basically theta minus alpha. Then this is going to be 0.98279 minus 0.28103. And then you will be getting 0.70176. And now I round up to 3 significant figures. That is 0.702. That is the least argument z for this complex number for the points on the locus. Alright, so I have completed the whole paper and also comes to the end of the video. Thanks for watching. If you enjoy watching my video, please like this video and subscribe to the channel, and also share this channel with your friends. Okay, and also stay tuned for more upcoming videos. Thank you everyone. Bye.